I'm now starting the first of a series on the North American plate. It's sort of slow to develop the geology of the North American plate, partly because I like to firstly define the plate and see what's going on today before we start trying to go into the history of it all. Now, I'm moving my picture well out of screen. You may not be able to see that, but I think that's the only way I can do it without it recording in the record. I'm moving now to try and get myself at least a little bit into the screen. Now that shows me on screen. All right, the North American plate. This is the first of a series that may take us through March and beyond on a fortnightly basis. And we tend to picture North America as I show it on screen now, the geological map. That means the colours on it are the age of the rocks. It's not the plate, it is just the North American continent. So there are oceans connected, certainly the Atlantic Ocean, or half the Atlantic Ocean is on the North American plate, as far as Greenland, the middle of Greenland. And likewise in the Arctic Sea, a lot of ocean. But to the west, the ocean is all the Pacific plate, and the margin of the North American plate effectively corresponds to the western coast of North America today. So there's fair complexity there. And in the Caribbean, we have a separate little Caribbean plate that sweeps through approximately just north of Mexico or Yucatan Peninsula and gets out through the Galapagos to the central zone of the Pacific. Now, there, the Precambrian craton of North America, that's the so-called Canadian Shield, is in red there, or shades of red and purpley colours. And they're the older rocks, the very much older rocks that were stabilised or cratonized, as the word goes, to form a stable block a billion or so years or more years ago. In fact, mostly more than 2 billion years ago. And it's clearly seen in the northeast of the map. And then extending down the eastern coast of USA, or Canada, USA, is the Appalachian Mountain System in blues. And this spreads out on the older rocks in lighter blue. They're about 500 million years or so. And they were cratonized or added to that about 400 million years ago. In the broad zone of the Rocky Mountains, extending from the west coast inland almost to the Central Plains and Denver and so forth, is younger than this. It's less than 400 million years and been added onto the continent or spliced on by the process of subduction. That is, the eastern half of the Pacific Ocean has effectively been swallowed up, and all the odd bits of volcanic arc or pieces of continent that were on that half of the plate are now crushed into the western portion of North America. So it's a fairly complex system, but rather like our Eastern Australia. In fact, it is the mirror image, and it started its life about the same time, 800 million years or so, with a rift that broke up Alaska, northern Laurentia, as the craton is known. That's the red zone, and the blues surrounding it were referred to as Laurentia before it was recognizable as North America. And that was initially annealed with the Australian craton. You might have been able to step off from Broken Hill to about Denver in those days, or even perhaps a bit further north into the Mackenzie Mountain System or somewhere in Alaska. Oh, we've got that problem. It is now not moving on. I have the same problem and everything has worked the last 4 or 5 times. I must have done it 20 times. But some reason it's stopped screen share, it stopped changing slides. I'll attempt to go through the process again and see whether it will start. Stop sharing, and Sealy features strongly there. Why would that be? I'm still recording, of course, but to screen share, I want to get screen share, and I want the most annoying. It's not working at all as it should do. Going back to that first slide or second slide, it is changing for me. I'd like to, no, I doubt very much that it's changing for you folk. I wonder if that is so. It is most annoying.
It's not, Bob. We've just got we've just got our little squares and you, but nothing else.
I cannot believe this happens again. Why is it so? I'm ending the show again. In theory, I hope I'm still with you. I've got Sealy featuring as strong, very strong. Is there some function with yours, Sealy? Are you got video on at the moment by any chance? Will you go down to... No?
I have not got the video on at the moment, Bob, but I can put it on if you want.
Well,
do you want me to swap across and see?
Well, yes. There you've got it off now. Oh no, that's your mic off. Yeah. But for some reason you feature on my screen as the dominant thing, and I can't do anything else. Now sharing screen for me, and I'll go back to from the beginning. Did anything change then?
Yes.
You haven't seen this one before. Have you not seen this one? You can't hear me.
Can you hear me, Bob? I've got a gallery of PowerPoint, of what look like PowerPoint screens.
No, well, that's not right then. Oh, blast. I'm so sorry about this, but everything I've done for ages worked all right, and this is now not working. I cannot understand. I will go right back to the beginning and come in. I think so. There'll be a blank for some period now.
Yep, that's okay.
I'm going to end and go and check in entirely once more.
Okay, Bob. Bob, I've still got all our little squares on my screen.
Hey, Bob, you're on mute. We can't hear you.
I know, but I can't.
That's it.
I just managed to unmute it because Sealy has disappeared from my screen. All good. Cynthia is currently host. Now, how the heavens did that happen?
Cynthia, have you got anything intelligent to say?
No, I don't want to be the host.
I know you can't I can't run the thing with you host, of course. Why is it so? Reclaiming the host may disrupt breakout rooms, polls, and screen share. Well, I'll reclaim host if I can. You are the host now, Bob. Okay. And most amazing features happen. Anyway, I'm whether I'm recording or not. Yes, I believe I'm still recording. So I will go back to the system and see what happens. Can you see the first screen?
Just writing on it.
Yeah, North American plate.
Yes.
Zoom by me. Good. Okay, well,
I've got North American plate too.
Okay, well, now will it change? It changes for me. Does it change for you?
Yes, that changed.
All right, well, we'll continue as we're going. That we've discussed. And
Okay.
all good?
Yep.
So this says Precambrian cratons, and I liken it to pack ice, taken in the Arctic, incidentally, but you get these older blocks that are dark, and I've got a yellow arrow where younger material has been welded on. It's ice in this case, of course, but it's welded on, often welded on almost symmetrically around the block, and it forms a sort of quilt with the older pieces broken up and rejoined by younger material. Geologists actually call it a collage. Quilt's another word you could use. So you piece it together, you might say, and there are sutures or stitches joining these pieces, which are the geological mobile zones, and often pieces actually move a bit or their joints are not as tight as they should be. But that's about the principle of for the plates growing, and they grow effectively by new leads occurring between the flow ice and expanding, and then more ice is added and they crush together and deform the ice, often pushing slabs of ice over one another as the wind affects them. So continents sit as passive parts of this floating plate, you might say, and new ocean material is being added to the outsides at a lot of the time. So if we picture the older blocks as greater than 2 billion years, then the white material has been added in the last 500 million years, for example. That applies to Australia and to the North American plate too. So if we look at North America, hopefully there's a slight change here. You see some numbers there. If you look at Superior right in the middle, you can see greater than 2.5. Well, that's billion years. And if you look right out on the Cordillera in the western side of North America, where the bushfires rage in past months, you see less than 0.4 billion years. So 400 million years or less has seen the addition of all that zone from the Yukon down to the Gulf of California and, of course, New Mexico and Mexico. And the Appalachian Mountains are marked as 0.4. So about 400 million years ago, a little earlier than the West, the Appalachian Mountain system up the eastern side through to Newfoundland and across into Scandinavia were added to the older craton. This process of cratonization or fixing as a firm quilt, you might say, goes on all the time. It's like adding border after border to a quilt. Now, of course, around 1912, not of course, but for about 50 years prior to that, geographers had recognized there was a pretty good match between Southern America and Africa, and wondered about the separation of continents. How could this occur was a worry to scientists, particularly 1912. We had a paper that suggested this was the mechanism of explanation for fossils, animals that had lived across two continents, and yet there was no apparent join between them. And we did discuss this on the previous series. And a big problem existed right through to the 1960s because no one could see just how continents could move apart in this way. But today we have very records of earthquakes, which show here that there are dense zones of earthquakes, which we assume to be plate boundaries. Notice Africa is pretty well defined, sitting in the middle of oceans, the Southern Atlantic, half the Indian Ocean, half the Southern Ocean to Antarctica, has defined Africa with surrounding younger oceanic rocks. And we can date those oceanic rocks. And we see that they're youngest along the central zone of the Atlantic Ocean, or around the mid-Southern Ocean, mid-Indian Ocean. They're forming today as basaltic volcanoes, and there is spreading of the plates going on at this in these zones, such that you're adding younger and successively younger zones of crust. Now, the North American plate is not particularly well defined. There's so many earthquakes across the United States, for example, it is difficult to understand what is going on, and it'll take us some weeks to get to that. But there's very strong earthquake zone along the west coast and extending westward through the Aleutian Arc south of Bering Strait, and that can be seen joining with Japan. But there's a very weak line runs across Siberia and right across the Arctic Ocean, and ultimately down between Greenland and Norway, Svalbard, and down to Iceland, and continuous with the central Atlantic zone. That zone, which is largely basaltic volcanism, is a zone of spreading, not over in Siberia, but throughout the Atlantic. It's a zone of spreading, as we know from Iceland, and extreme basaltic volcanism forming new ocean crust. The ocean crust is quite different in composition to the continental crust, such as Greenland and Norway. They're older rocks, sediments, granites, etc., whereas they're relatively light and tend to float, you might say, on the heavier mantle. The plates appear to be about 100 kilometres thick, and they seem to be spread in these mid-ocean regions by hot, I'm thinking of the word convection currents, which come up from very great depth in the mantle and then spread out laterally, impose a drag on the plates that pulls them apart, and the volcanism passively fills the rift. So that's the secret of the eastern borders of the North American plate. If we look at this on another map, it's always very hard to show the North Polar regions, but this grey North American plate has some surprises because it's quite simple, well, not terribly simple, but it runs up the central Atlantic in a pretty straightforward way, a bit complex, crossing through the Caribbean region to the west of the United States. But we notice that the Pacific plate is right over against that North American plate with little patches of blue in there. There's Juan de Fuca, or its neighbour, which is split off at the Kirkus plate. Well, they're the other half of the Pacific. So in fact, the North American plate has moved over half the width of the Pacific Ocean. And the reason it's so complex across the United States is that half the Pacific is sliding in under there. Hence, you've got a very wide Rocky Mountain belt, 500 miles or so. And we will look at that again at a future date. But we'll move on and look at the Arctic Ocean shortly. But you can see here how the United States Geological Survey actually shows the boundary of the North American plate running down through Siberia to Japan, to actually include Hokkaido and northern islands of Japan, cutting back along the subduction zone, which recently caused the tsunami, or 5 years or so ago, tsunami and damage to the nuclear plant in Japan. It runs back up to the Kamchatka Peninsula, and then way across as an arcuate volcanic belt across to Alaska. So it's a complex boundary, and to most people's surprise, it may currently include a portion of Japan on the North American plate, the northern sections of Japan. We'll go into that in more detail, and possibly not the best alternative. Here again is that plate. If we can look in the north, we can see in this particular map, right up at the top left-hand corner, Okhotsk plate includes that Kamchatka Peninsula, but it doesn't include the islands of Japan. So there's a strong case for arguing there's a small plate that's been fractured off the tip of the North American plate, which is actually moving in that direction. Underneath that Okhotsk term in the top left, there are two little arrows, 18 and 16, indicating the movement in centimetres per annum. So there's a strong movement, we can say, towards the top of the diagram. I won't be able to say north there because you can see where the North Pole is on the American plate, not on the Eurasian plate, which is its neighbour there. Even though the Russians planted a flag under the ice there on the North Polar position, it's the geographic pole, of course. We have a red line with little patches of green in that line running all the way down the that right-hand side of the North American plate. Its junction with the Eurasian plate, it's effectively separating or sliding past for most of its story, whereas green are areas of pressure where the plate's actually pushing, and that, of course, is to a major part in Siberia, or else it's overriding the Pacific plate where that blue boundary occurs west of Alaska or south of Alaska in the left-hand portion of the diagram. So we've got plate boundary running, expanding essentially all down the northern Atlantic through into the Arctic Ocean, becoming a crushing zone through Siberia and a subducting zone as we pass the Kamchatka Peninsula, that Okhotsk location, and then it's overriding, or else the Pacific Ocean is subducting underneath it through the Aleutian Arc to Alaska, and also in places down the western boundary of British Columbia and through as far as California. Whereas in California, it's a sliding plate in green. The Pacific Ocean is pushing northwards at 7.6 or 7 centimetres a year, and the North American plate is likewise pushing westerly, as we can see from the arrows, which show, I think, 29 there in central North Canada, or maybe 19, I beg your pardon, 19. So those plates are opposed, and in places it's subduction, in places it's a sliding fault. It applies to San Andreas running through California, of course. Again, in the south, against the Cocos plate, the Cocos plate is slipping in underneath the Gulf of Mexico and Mexico proper. A junction occurs where I've encircled it south of Yukon Peninsula, right on the southern central portion of the map. And then you have a sliding type boundary all the way across to the west central zone where there's crushing going on as a result of interaction of expansion and sliding. We'll go into the Caribbean plate a separate day, but we've had quite a story going around the American plate there. looking at it in a little more detail, of course, the ridge zone through the North Atlantic was probably the first one, it was the first one identified. So in the 1950s, the Cold War period, there was a lot of activity in trying to trace submarine activity. And this was done by looking for magnetic objects that were moving at depth. And they realized that the ocean floors were magnetic and had a striping or banding, which reflected the Earth's magnetism at the time the basalts were formed. And in fact, they also discovered that the Earth's magnetic field had flip-flopped or changed north to south every million or two or every few million years over time. And north became south by the pole sort of wandering around and finally finding its position totally reversed, a bit slower than an AC motor, but the same sort of effect, because the magnetic currents are generated from some sort of current activity in the liquid core, which surrounds the solid core of the Earth. And it then has 3,000 kilometers of mantle outside that, which is capable of some movement, in which the convection currents occur that drive the plates. But the outer 100 kilometers is lithified or rocky. Lithified just means turned to rock. And they're the solid plates that are being moved by these currents in the mantle. But the currents in the core apparently generate the magnetism, and that of course is liquid nickel iron and has the composition of magnets. So something goes on there that we don't understand. Anyway, that it was discovered that there was a central ridge or ridge and valley situation running down the center of the Atlantic where the earthquake foci concentrated, shown here by little black dots. And these clearly define a plate margin at which spreading is occurring and growth of new oceanic crust takes place. And this can be witnessed in Iceland, as we just said in our first indications, in our first series of talks, although there may be some sort of jump going on there with the central ridge being displaced somewhat in Iceland itself. Maybe the reason it's actually appearing as an island, and one of the few exposures of the central oceanic ridge that there is to see. Now, I didn't finish, but in looking for submarines with magnetism, they identified a zebra-type striping on the ocean floor of magnetic reversals, which when we were able to date rocks very readily from samples collected at depth, it was found that, with the new entry, I can't change slides. Something goes on there when we get a new entry. I do apologise. I'm now caught in this situation of being unable to continue. I wonder if we were to check out in order of appearance. I didn't even take note who it was coming in at last point, but would you kindly check out and we'll see if we can continue changing slides, because something goes on with interruption of other people. Nope, they're not changing. There's a new share going on. I don't know whether that will help. No.
So, Bob, do you want us to cancel out of the session, do you?
I don't actually know who I just admitted. Somebody came in and I admitted them, and then it wouldn't change slides.
I think Tricia was the last one to come on.
Yeah. Tricia, can you actually hear us? You are muted, I guess. But I wonder, Trish, if you're receiving this, would you kindly check out again, and we'll see if I can continue with the talk, because it's somehow taken over. I presume it takes over the leadership of the talk when someone's admitted, which it shouldn't. No, it's not helping me. I think, can you all see the slide of Iceland and the Eurasian plate?
Yes.
Yes.
Right, well, best I can do, I imagine, is talk to that for a minute or two and then close off for the day, because I'm just at a loss as to what goes on with the system. Let me say that you can see here the division between the North American plate and the Eurasian plate. It's a ridge in the subsea at very great depth, of course, probably 5 kilometers or so down. And it's active volcanism. Probably every one of those black dots is actually a volcano at depth that might erupt every 50 years or something like that. As they are on Iceland, you'll notice the black dots and all the triangles in red are the more recently active ones on Iceland, probably historic ones, I'd just have to guess. And currently there's one acting in the very southwest corner, just south of Reykjavik, between there and the airport. And that appears as a rift, started about April, I believe, and is currently reduced more to a hot cauldron or two with a whole lot of geysers or geysers, whichever way we want to pronounce that. A volcanic field that stretches several kilometers and has infilled a valley with basalt. And that's presumably the way the entire central ridge is built up of volcanic basaltic rock. And it's quite dense rock. It certainly gets denser as it cools and continues to move laterally, that is eastwards, adding on to the Eurasian plate, and westward, adding to the North American plate, and separating the two plates in the process so that new volcanism occurs right along the central rift. It is complex because we can see Iceland, the volcanoes are not necessarily right in the rift situation all the time, but in general, you get these broad bands down the center of the, or parallel to the center of the North Atlantic Ocean. And they date, 0 years in the current rift. In fact, you can stand in the old rift zone in Iceland with one foot, they say, on the American plate and your other foot on the Eurasian plate. And that's where they held the very first parliament, they say, about year 1000. In fact, in the year 1000, I believe Iceland decided to go Christian at that parliamentary session where all the Nordic lords would come in and meet, and there'd be marriages arranged and fights settled, no doubt. And of course, people were banished, like Eric the Red, to Greenland in those years. Greenland was fairly accessible, even for farming, a lot warmer, or a bit warmer than we are promised today. Suffice to say, the continents on either side, such as Great Britain and Greenland, are much older rocks. In fact, you're talking billion-year-old rocks in places, and they've been displaced, but not directly so. Scotland, for example, probably was up near Iceland somewhere before the initial rifting 60 to 80 million years ago, and it has moved south, northern section of Scotland, and joined on or sutured on to the rest of the British Isles. But the British Isles and Newfoundland, Labrador, Newfoundland, which is just sort of poking its nose out under that term North American plate on the west, show a much better match in their geology. And so there is a suture through almost on Hadrian's Wall and running through Central Ireland, which also appears to run through, I think it's called the Red Indian Rift or something in Newfoundland and then into New Brunswick and continued down towards New York. And that suture or stitch up is of an ancient ocean earlier than 400 million years. Not only that, there is a second suture suggesting that an ancient ocean existed which runs through southern England and southern Ireland and goes off towards the Baltic. And that appears in eastern Newfoundland and is known as Avalonia. I don't know whether Avalon got its origin from this very ancient slab of continent, which can be demonstrated to have come from Gondwana, from a join of Africa and North and South America, a slice that might include Morocco and say Venezuela and so forth, separated at a younger time than the ocean that I referred to along Hadrian's Wall. The northern one is perhaps you might say the first Atlantic, the southern one, the second Atlantic. We will go into this in future using slides. So there have been at least 3 Atlantic Oceans open and have stitched more or less along the same zones, which are evident in the surrounding continents. There was always a great problem with the fossils of the British Isles and Eastern Canada, particularly Newfoundland, because they just didn't agree with their appropriate positions. And it's now worked out that they were formed in different oceans at different times and jostled around and repositioned in these continents. And once the story is put together, it now makes sense. A geologist by the name of Wilson worked out that you have a sort of cycle that massive groups of continental material join together and form a supercontinent. And this happened about 400 million years ago at the time of closure of this Avalonian Ocean. I won't use the names of them at this point, I need slides to help, but the younger of the 2 oceans, of those 2 that I mentioned before, the older one being the one along Hadrian's Wall. And suffice to say that I've lost the thread a bit there. Anyway, the oceans closed and have reopened. I'm trying to think of what I was driving for, but no matter. The sutures are not exactly the same, but there must be a gross weakness in the crustal material because they do tend to separate. The bits stay behind at times. And certainly this applied and can be elucidated because so much geological work has been done. Now I'm coming to it. Wilson was the geologist who thought of this cycle and decided that you could get a rifting in a massive continent like Africa today has a huge rift, the East African Rift, it's known, which runs from the Red Sea right down west of Tanzania and will split off those eastern provinces of the country, Tanzania, Kenya, etc. ultimately, and a new ocean will presumably develop. The next stage of an ocean from the splitting of the supercontinent is a narrow ocean like the Red Sea. And that is a true ocean and would have expanded in the last 50 million years had it not been trying to push Arabia into a massive block of Eurasia. And it's been thwarted in developing as a big ocean. Whereas in that same time period, one developed pushing India all the way across the Indian Ocean, creating the Indian Ocean of today, closing oceans in the north and crunching into Asia to make the Himalayas. Well, suffice to say, going back to Mr. Wilson, he thought of it as a cycle that these things opened and ultimately closed again and open and close. So you get a cycle of supercontinents. And these are known today as Columbia, or say 1.5 billion years, and about 1 billion years ago, Rodinia, and about 500, 400 even million years ago, Pangea, were the three major supercontinents in this region of the world that have opened and closed. And the reason is the formation of a new ocean, the most recent of which is the Atlantic. And we will go into that in a future discussion. Well, I have this slide showing, we can see a lot of earthquakes running through from the central Atlantic ridge, easterly, just near the E of ridge, running easterly through Gibraltar, getting into a very complex situation in Italy and the Alps. And to be looked at in this series of discussions, but worth commenting that the intense earthquake activity running into the Alps today is due to a ton of material, the Ligurian plate, which has been pushed from Africa out over the Alps, so that the top of the Matterhorn is actually material that was probably deposited 70, maybe 100 million years ago on the margins of North Africa, and now finds itself thrust across older rocks of the Alps and sitting at the highest point of Europe. Perhaps at that point I will close and we'll see if we can get a discussion and questions going. So I'll just stop sharing and see what cooks. And now we have Cynthia very strongly recorded on my screen. What do others have? Please engage your mics in the bottom left-hand corner, unmute yourself, and let's see what cooks.
Well, I think we lost the person who came in late.
I did ask them to drop, but it didn't improve. I couldn't change slides again.
Right.
Kept trying. Yeah, crazy, isn't it?
It doesn't make sense, but perhaps Suzanne's tech-minded person.
Yeah, well, so that ultimately that recording won't be any value really. It's quite off the point and no changing its slide. Now, the only one with video turned on is Suzanne at the moment. Is anyone else going down to the bottom left to switch on? Yes, thank you, Kay, I've got you. And Graham and Seeley, good. I'm sorry, I don't know if anyone can ask why it is that it seems to jam up if someone else comes in. I know, yeah. Anne Miles, are you there? Would you like to go right down to that bottom corner and click on
Yeah, yep.
Yep, good. Good morning.
Yeah.
Yeah.
Good morning.
I don't recall now, when you came in, did I then immediately have trouble changing slides, Anne? Because
no, I don't think it started.
not at that point.
No?
Yeah, it seems to be what I won't do in future, I suppose, admit people who come in late, because it seems to cause a problem. There were, I think there was a little problem earlier than that too, but I tested and tested so many times, you wouldn't believe. As I said to Kay this morning, the last 5 times since 11 last night, that's worked okay. Now, questions, anyone with questions? Yeah, sure.
Despite the technical problems, it was very interesting, Bob. Thank you.
Hardly, but still interesting to record that we've got volcanic activity in Iceland at the moment, and it probably shows that sort of 2 or 3 years out of 10, you do have a volcano erupting there, and that probably goes on for about 50,000 kilometres under those central oceanic ridges. If you measure them around the globe, the Southern Ocean around us and the Central Pacific, admittedly, the volcanism there is reflected in things like Mount St. Helens, which of course is where the continent has overridden the central Pacific ridge. And we'll have a trouble describing all that later when we've got slides to develop it. Any question?
Bob, it's not a question, but I'm just looking. You've got your main screen with all of us.
Yes.
There's another screen behind that, which is flicking on and off, and it looks like part of your lecture or something, and I can't quite.
People.
People.
It's sort of cartoons of people.
There's
nothing to do with me, I don't think.
Well, I'm not sure what's going on there.
Is anyone else seeing that? I'm not.
No.
I see it.
It's right down the bottom. It's just a thin.
No.
And that's.
If I go to the bottom, the only thing
My
I get
mind seems to be interference. The other thing is that that's full on.
I saw something like that, Bob, when you first came on. There was, like Graham said, cartoon stick figures, just very, very briefly when you first came on.
Oh, it shouldn't be. It doesn't ring a bell with anything that I have in my computer at the moment.
So there's something happening behind that screen.
And it's cyclic as well.
Yeah.
The only thing
here we go. I pulled your screen down.
Yeah.
And what on earth have we got? So we've got Zoom, but it's the original. It's the original Zoom telling us, well,
open Zoom meeting.
Well, actually, right now there's an open Zoom meeting. Should that be cancelled off? Accept cookies, you know.
Goodness, I haven't got that showing.
That should be.
I can't move your screen down. No, I can only close it.
Oh, now I've lost that screen. That it's pulled right off.
No.
I can't move all our pictures away. I've got a white screen behind it. And
well,
won't move.
Well, I just changed them then using the little blue thing that features, you know, the little blue tick in my top right screen.
For me, you know, for our screen, that accept cookies should have just been clicked off, you know, accept the cookies because you have to.
All right, now I've just gone.
Now I can't drag the actual.
Right down to the bottom.
It's now gone. Hang on, I'll do this.
Got it
Of course,
now.
you're not controlling us in any way.
No, no, it's now I've pulled it back up. Yeah.
Now, the rest of you.
So I've got all the photos of the people, including yourself, Bob.
Sort of the 7 screens set out in the main body of it.
Yeah. So there's a whole layers of screens.
Layers, gosh.
Well, I think that's more to do with perhaps us.
Yeah, well, it's certainly not featuring with me. Anyone else
actually
No.
bring the thing up, I think. But
let me ask, is anyone else suffering that sort of problem?
No.
All I've got behind the main screen is an ad for Zoom Pro. And if I enlarge your main screen, then I've got nothing except the enlarged main screen working perfectly.
I can't actually fiddle with the main screen.
I've got a white screen. It says Zoom and a plain white behind all our pictures, but I can't move this set of pictures at all. I can't move it up or down or either side.
No. Well, I'll change that view back to speaker. So it should record whoever's speaking, I'd have thought.
Bob, I'm going to sign out because I can't make any of these manoeuvres on my phone, so I can't be of any help at all.
Oh, thank you. I'm sorry about that.
No, that's not your fault, but hopefully you get it solved before next fortnight.
I've recorded the whole of this, so I'll
Yeah.
try and ask an expert to look and see what the problem is.
Yeah.
Okay, bye
Yes,
everybody.
there's something.
Bye, Suzanne.
Thank you, Bob.
Radio. And Graham, if you wanted, we can fiddle around together if others are happy to leave it now, and just see whether we
Yeah,
can
all right, okay.
improve matters.
Yes, yeah.
I'm going to leave it. So goodbye.
Do you want us to leave, Bob?
No, you can
Thank
you
you.
can leave if you so wish.
Yes, I'm going to leave.
I'll leave, Bob, because mine's working fine. So
Yep.
thank you very much. We'll see you at the next
I
one.
wish to hell it had changed slides for us, that's all. I don't understand that.
Yes,
Yep, some are going, some are going.
yes, yeah.
Well, Graham, there's one thing I'd like to do.
Yes.
See, now, there's participants. I recorded at the moment participants 4. If I click the participants down in the bottom there, just wondering what it does. Oh, it shows that who those participants are up on the right. Yes, and it shows I'm talking, and there's Anne and Stevie
Yes.
and yourself. Yes, I see. That's all it does. But if I can actually mute all. If I click that, mute all
Yeah.
current and new participants. Yes. So you can't. Will you try speaking now? Yep, you're muted, so I won't mute all current. No, so you should be able to speak again now. Yeah, so I can actually physically cut you off by going through participants. But there's also a chat screen, which allows muting all or allows chat. Okay. I guess we're chatting. Can you speak again, Graham?
Yeah.
Yep. So we can all speak.
So, hello there. Did you people get that hello there?
Yes, no problem. Yep. So I was just checking what those things actually do. Participants and chat, they just give me more view on my screen as to what's going on with people. But I've no idea why a new admitted person would cause a problem with changing slides. And going back, I'll go back through change screen and see whether that will allow me to do that. If I use screen share. Now, no, I still can't change slides. So that's amazing, isn't it?
I just got all of us down the right-hand side, and the screen, the last screen that you had on as the main thing.
Yep. Now I've changed it back to the slide view with all the things illustrated.
All the plates.
There. Yeah. And I do have the Zoom screen as a background.
Yeah.
A leader in the 2021 Gardener Magic Quadrant for Meeting Solutions. That does appear mostly behind, if I can get back to that, but I'm not particularly worried by it. I would normally then go down to the bottom screen and turn on my North American plate things, and I would go from the beginning on the slide sorter, and it comes up as the first slide, and it changes for me. Is that changing for you people?
Yes.
Well, that's what I want.
Yeah.
But that only worked until somebody checked in. So we got through that series of slides, and that's where we stopped. And we were going on to show the National Geographic presentation of the central Atlantic Ocean. And you can see the continents sticking up there relative to the ocean floor. They're lighter rock, of course, the continental material. compared with the basalts of the ocean floor. And that's the diagram of how that basaltic magma comes up from depth to the bottom of the rigid plate at 100 kilometres and then erupts as volcanoes. And the movement of that convection current in the mantle at below 100 kilometres actually drags those plates apart, and the volcanism comes up fairly passively in places like Iceland and all the way around that ridge. And of course, I've got a yellow fragment I've drawn on there, which is just a fragment of continental material that happened to be around, being carried passively away as the Central Ocean expands. And that's a geological map, which we'll go into next time, showing the ages of the rock bands away from the centre, which is the red line, the central ridge, and they're symmetrical on either side, so that you might say the yellow bands are 20 million years, the orange outside that would be 40 million years, the brown about 60 million years, indicating that the Atlantic Ocean opened 60 to 80 million years ago. And so also a belt running up the strait between Greenland and Canada, Hudson Bay region, or the Arctic Islands. But that was what you'd call a failed rift, never opened fully, as did the northern one into the Arctic Ocean. And that's the pattern of the Wilson idea of a continent, a supercontinent being rifted, heated from below, probably stretched and up-arched, separation occurring, basalts starting to form oceanic material, and then ultimately spreading like the Atlantic of today and going back to the National Geographic map. I think I'll call it a halt there. Just means we've got a lot to go to get around the full plate, but it gives me a starting point. Sorry about that. Any questions before I close off? Got a chew, chew going on, haven't we? Can you all hear that? Chew, chew. No? Oh, everyone's muted, of course. I better go to more. Not showing where. Goodness, things change up the top too sometimes. Chat anyway. Oh, I don't want to write chat. Participants. Yeah, mute or unmute. I shouldn't. I'm not. I can't unmute you. You have to unmute yourselves. How about that now? Graham's still muted. Graham, Anne is not.
I don't think I am I?
No, you're not muted either, Seeley.
No.
But Graham is. Oh, well, now Anne is muted now. You just switched it, did you, Anne? I don't believe I can change you.
Yeah. I don't know.
Oh, yes, I just put you on unless you did.
I'll now.
Yeah, you're on now too.
Thing. You can't click on the little red one. You have to find a blue one too, on the diagonally opposite.
It's worth us testing, isn't it?
Yes. The trouble is, I know nothing about Zoom at all. Unfortunately,
clearly, I'm still discovering all the time. But we will close it all now. Otherwise, I'll have you occupied all morning unless anyone wants to do any more.